Hello, everyone, and welcome to our lesson on half-angle formulas or identities in our Chapter 7, 7.6 notes. Today, we're going to learn about half angles. We've learned about double angles on our last lesson. Half angles are for special cases where we work around the unit circle. So what we've been doing is trying to add to our unit circle here of the angles that we can compute exactly. So in our first lesson, we did angle sum, where we could take any two angles we know around our unit circle and add two angles together and use our angle sum formulas to find them, sine of alpha plus beta, and so on. So today what we're going to be looking at is half angles. Can we take any angle we know around our unit circle and work with finding half of that? So for example, half of 30 would be 15 degrees, or half of pi over 6 would be pi over 12. So you're going to start seeing radian measures you're not as used to that we're going to be working with finding and computing half angles. So before we do that, let's go ahead and take a look at where does this formulas come from, or the identities come from. So if we let alpha equal x over 2 for some cosine formula and solve backwards for sine of x over 2. So this is one of our double angle identities from the other day. Cosine 2 alpha equals 1 minus 2 sine squared alpha. So we're going to replace it, and we're going to be finding backwards. So we're going to take out alpha and replace it with x over 2 in both locations. So when we do that, we get our next step where we have x over 2 substituted in wherever there's an alpha. And then on the left-hand side, it will clean up. The 2's will cancel down to just cosine double angle, or excuse me, cosine x. And so now what we're trying to do is we want to solve backwards for sine of x over 2, which is right here on the right-hand side. To do that, we need to move the furthest piece away from that is going to be 1. So we're going to subtract 1 over and just go through our operations. So subtracting 1 over, we're left with 2, negative 2. Okay, sine squared. So then what's our next step for getting it alone? Solving for sine of half angle x over 2, we need to divide by negative 2. Okay, so you'll see that step right here on your notes. And then what we'll have to do is, yes, it looks a little intimidating, but I'm just going to switch around and take a look at it and move this negative on the denominator, apply it more to the numerator, and make it positive 1 and negative cosine x. And so that will equal a quantity squared of the half angle x over 2. So what we do with that last piece then is we are going to go ahead and solve for the sine of x over 2, which is what we're looking for. So we would square root both sides because we have a quantity squared. So we would square root both sides and get a plus or minus the square root 1 minus cosine x divided by 2. All right, so that is going to be called our half angle identity for sine of x over 2, or a half angle. So that is where they're coming from. And we're going to be able to evaluate, like I said, angles around our unit circle that we cut in half. Now we could do angles that we already know. For example, if we took 120 and we cut it in half, we would get 60. We already know how to compute angles of 60, but that could go into this position where we would put a 120 in for x and a 60 in for 120 in for both x's, excuse me, and we'd get 120 divided by 2, and then 120 over here on the right. So one of the things to note that we worked with our double angles, and I'm going to go ahead and move this unit circle a little bit more out of the way with this, let me get that over there, is when we worked with our double angles the other day, we did a problem similar to this where we said it's true that cosine of 120 degrees is equal to 1 minus 2 sine squared of 60 degrees. Okay, so a double angle identity has a double to half relationship. So this piece right here is double, and over here is a half relationship. And so what's going to happen today is those are going to become reversed. So when we see this formula down here, if we have sine of, let's say 112.5 degrees, this is going to equal the square root of 1 minus cosine of double that, which would be 225 divided by 2. So they are kind of interesting formulas. They are going to be a little trickier to simplify, but that's what we're kind of be looking at here, that double to half relationship. So this piece right here is going to be half, and then in the formula itself, you are going to double. And that's partly because this piece right here is 225 divided by 2, which is what you're looking at in our half angle relationship. So you can pick any angle we want around the unit circle and cut it in half. And sine of 112.5, how do we work with this plus or minus? And I'll bring it up a couple different times. We are taking the sine of the half angle. So sine of 112.5 is in quadrant 2. So sine is going to be positive. So you pick the plus or minus based off of where the half angle lies. All right, so let's go ahead and take a look at the formulas for these. You could use the same process here to find the sine and tangent angles as well, cosine, half angle also. So half angle formulas, they will be given. You'll have your formula sheet already loaded up for you. So these are our formulas. Tangent has a couple different varieties of formulas that you can use. I do recommend the last two much better than the first one where you have to deal with a plus or minus and a square root kind of mess with that. So if you can avoid the first one on tangent half angle identity, it is helpful. Actually, I do prefer even this last one because we only have one term on the denominator when possible. Okay. All right. So here is our purpose. So we're picking any angle we know around the unit circle, and we're finding the exact answer of its half angle using these identities. So 45 cut in half, 300 cut in half. Sometimes it makes more sense to use the half angle identities than other times because we already know how to evaluate 150 degrees. So why would we apply the half angle identity? But it will still work. And true for 45 cut in half is 22 and a half. So you're going to see a lot of decimals working with this. All right. Example number 1 says simplify the expression in terms of A. So these are one of our backwards problems. I call them kind of our Easter egg or hide and seek. So we're going to look at our identities. And yes, we're focused on half angles today. Where does this identity land with this? And if you take a look at this, this is equal to tangent of x over 2. So it's equal to this one right here. But it's not just x, it's 6a. So here what we have is where x equals 6a. So I'm going to substitute out wherever there's an x, and I'm going to put tangent of 6a divided by 2, which will equal tangent of 3a. Notice this half value, so 3a is half of what's in the identity of 6a. So it's a half to double relationship, right? What we're talking about right up here, half to double in the formulas, identities, okay? Example number 2, evaluate using a half angle identity. So you are going to be seeing more radians that you may not be familiar with on that. And it says here, determine if the plus or minus from the angle that it's given. So we're evaluating cosine of 3 pi over 8. So you can do this a couple ways. You're going to start, you kind of almost start by doubling. Because really what this is we're trying to find x over 2. So if we kind of come back up here a little bit, all of this left-hand side, we're evaluating one of these. And so this has been cut in half. So if we double this, we can actually figure out what we're looking at with that. So it also may help for some students to actually convert that into a decimal version or a radian versions of that. So this cosine of, cosine of 3 pi over 8 has been multiplied by a half. So if you took a half out of this, this is equal to cosine of a half times 3 pi over 4. So we're evaluating half of 3 pi over 4. So if you are working with angles, what we're actually looking at, and you could convert this, you can take 3 pi over 8 and times it by 180 divided by pi, and you're going to go ahead and get 67.5. So it's not a great angle with that. But if you look here, it's half of 135, which is 3 pi over 4, if you wanted to convert this. So this is equal to cosine of 135 divided by 2, okay, which is 67.5. So you can leave it in radians. You can switch it to degrees with it, whatever you like. So remember, our steps for these problems is to pick a formula and expand it. Okay, so we're going to go ahead and do that. So we're asked to find cosine of a half angle of 67.5 degrees, which is 135 divided by 2. So we're going to be using this formula right here. So this is going to equal, and I'm going to put both the plus or minus here, and I'll show you how to pick out. I like doing it at the beginning, but you can bring it back up at the end if you like. So we're going to pick an angle and expand it. Step 2 is to sub and evaluate what we need to. So you're going to substitute into the equation angles or ratios. It just depends on what you're working with that. So for this particular problem, we are finding the plus or minus comes from the given angle. So since we're evaluating cosine of 3 pi over 8, 3 pi over 8, also 67.5 degrees, is in quadrant 1. And since cosine is positive in quadrant 1, we are going to have a positive out in front. So I kind of like to do that right at the beginning so I don't lose it, or by default just leave a plus sign. But you're evaluating this angle because what gets a little confusing is when we put it into the formula, it's going to be 1 plus cosine of x. So cosine, our x is the numerator right here. This is x over 2. So it's going to be 135. So we have a half to double relationship with our identity, and the denominator is 2. All right, so it looks something like that. So this is going to be equal to the plus sign. So I'm going to kind of just bring that along with square root of 1 plus, what is the cosine of 135? And the cosine of 135, it's in the second quadrant. So again, we have a positive out in front, but we are evaluating cosine of 135, which is negative square root 2 over 2. All right, divided by 2. Now, from this particular part, the problem can go a couple different ways. You do have to simplify it a little bit further. There's a really nice strategy for doing that that avoids kind of getting a compound fraction divided by 2 and then multiplying by the reciprocal. So I have taught this in a couple different ways, but what I do recommend is whatever you do to the numerator, you can do to the denominator, and it will be a proportional fraction. So for example, if you have 3/7 and you multiply the numerator denominator by 2, you would have 6 over 14. And it's like an equivalent fraction. So I'm going to multiply by the common denominators. If we look at all these pieces, we have 1 over 1, negative root 2 over 2, and then 2 over 1. So that common denominator is this 2 right here. So I'm going to multiply the numerator and denominator by 2. So it's a very helpful strategy that helps work out pretty nicely. So I'm going to have plus the square root. 2 is going to be multiplied by everything in the numerator. So this 1 by 2 times 2 is going to be 2. And then negative root 2 over 2 times 2, the 2's will cancel. We have negative root 2 divided by the denominator is 2 times 2, which is 4. Okay, and then the last step for this simplifying, like I said, step 3 I should put over here is simplifying, is a little trickier for half angles and anything like tangent where you have fractions involved. The last little piece that I'll normally see this reduced to is you have the square root of the numerator over the square root of the denominator, which is 4. The square root of 4 can be nicely written as just a square root of 4 is just 2. So this is going to become plus the square root 2 minus root 2 all divided by 2, the whole thing, because the square root of 4 simplifies down to just 2. And this is going to be our exact answer for equaling the cosine of 3 pi over 8. All right. And so it's a little bit confusing. It's a square root in a square root is actually acceptable to be simplified down. So it's the first time we've kind of probably seen that happen as well. All right, let's go ahead and try that one more time and see if we can get the pattern. So again, we start by kind of doubling or working with a half relationship, but inside the formula goes an angle that's twice as large as the one we're evaluating. So if we're evaluating 67.5, then in the equation, we are going to evaluate 135. There's a double to half relationship. So this is half of what goes into the identity of the formula. All right, so we're going to evaluate sine of negative 105. Okay, so we're going to use this using half angle identities. So there's a couple ways to work with this. So again, let's write that as a fraction. So that is equal to sine of negative 210 divided by 2. That is equivalent to 105. So you start by doubling your angle that you're working with. One thing to note that we have discussed before is we could use the coterminal. So the coterminal angle of 105, if you rotate negative 105, you're right here. What would be the positive rotation? You could use 225, 255, sorry about that, 255 as double. This is the coterminal answer. But when you go to the formula, then this would have to be equal to double that, which would be, looks like 510. So this is equal to sine of 510 divided by 2, which gets a little intimidating to work with the angle of 510 in the formula, but you could do that, okay? All right, so this is gonna equal, we're gonna use our sine formula, okay? We are evaluating sine of negative 105, so that goes right here. This is in quadrant 3, so sine should be negative when you evaluate it in quadrant 3. So when I start this problem, I'm going to just scan up back to the formulas. So our sine half angle, these are identical looking, except for sine is 1 minus cosine x, and cosine half angle is 1 plus cosine x, and they're both divided by that 2. So be very careful when you write these down. They both involve the cosine ratio, but one is minus, one is plus. So just make sure you're rewriting the correct formula down. So we're going to pick a formula and expand it. So this is going to equal negative, because we're in the third quadrant and we're evaluating sine of negative 105, square root 1, and the cosine function is, so it's going to be minus cosine, I'll put an x here temporarily right now, x divided by 2, just to kind of make sure we're not losing it. And this piece right here is x divided by 2. So we're going to have negative square root 1 minus cosine of negative 210, so that's twice as large as the angle we're evaluating, which is negative 105 that we've written as a fraction, all divided by 2. Okay, and then we have to evaluate that. So I'm going to bring that down here to evaluate just so I have some space. So we have minus the square root, 1 minus cosine of negative 210. If you need a picture, your new negative 210 is going to put you right here in the second quadrant with a 30-degree reference angle. So we have 1, 2 as our hypotenuse and negative root 3. So the cosine is adjacent over hypotenuse, or you can do the ordered pair unit circle, whichever you like. We had that up at the beginning. So this is going to be negative square root 3 over 2. So be careful not to lose that negative as well. And then this quantity is divided by 2. Okay, so that's kind of our setup. So we've done the pick a formula, expand it, and now we've substituted the ratio of cosine of negative 210 into that fraction. Now what we have left to do is simplify. So again, the strategy to do this, because we have a fraction in a fraction, is to multiply by the common denominator for the numerator and denominator to keep it balanced. So I'm going to put CD for common denominator, and that is going to be this 2 again. So it's very common to see a common denominator 2. When we look around our unit circle, a lot of them are 1 over 2, root 2 over 2, and so forth, root 3 over 2. So this is going to equal negative square root 2 times 1. So we're going to multiply this 2 across the whole thing. So again, you can even put brackets around it if you needed to. So the 1's going to become 2. And there's a double negative minus a negative root 3. So it's going to become plus square root 3 because these 2's are going to cancel right here, and all divided by 4. And similar to this upper problem, the square root of 4 on the denominator can be reduced down to, so our numerator is going to be 2 plus root 3 in a square root. So we have a square root in a square root divided by 2. So make sure your fraction is long enough that it's showing the whole quantity is divided by 2. You can even put a 1/2 out in front if you like. I have seen that as well, where it's minus 1/2 times this. So I've seen it like this, negative 1/2 square root 2 plus root 3 is also an equivalent answer. So that's how you can see equivalent answers with that. Okay, all right, so that's 2 angle problems where we're actually working with a numeric value given either radians or degrees. Some students do prefer switching it into degrees and then doubling it and working with it. It's completely your choice. Okay, here's our next example. If cosine of B is 2/3, find the exact value of cosine of half of that angle, where angle B is an acute angle. All right, so this is one of those ones where we're provided one of the ratios is 2/3. All right, so I'm going to go ahead and kind of set up my picture. B is acute, so if it's acute, it must be in the first quadrant. Here is, it's B, I guess it's not quite beta. So there's B, angle B. Okay, cosine B is adjacent over hypotenuse. So my adjacent side is 2, my hypotenuse is 3. We could go ahead and even find the missing side if we'd like. I'm not sure if we'll need it or not, but just for good practice, 2 squared plus, let's say, this is my y coordinate, so I'll call it y squared. I was going to call it lowercase b squared, but we have an angle b, so we'll kind of avoid that, equals 3 squared. So this is y squared equals 9 minus 4. So y is going to equal, y squared is going to equal 5. So y will equal the square root of 5. So if needed, we have a non-triple here, but we have all 3 sides of the ratios of this triangle. And even though we're not computing angle B, it's an acute angle, and we're finding half of that. Okay, so if we're finding half of that, cosine of B divided by 2 is equal to plus or minus the square root. So we're going to use our formula, 1 plus cosine of just B cut in half. Okay, so expand your formula out. Since we're acute and half angle, if we take an acute angle and we cut it in half, this is going to be in the first quadrant as well. So we're going to stay positive for this. So this is going to be positive square root 1 plus, I'm going to put kind of a placeholder there for the ratio of cosine B. So cosine B we are actually even given. So this problem, we wouldn't necessarily have to set up this picture, but just in case we were given the sine ratio or tangent ratio, we're going to sub in the cosine ratio of this angle, which is 2/3. So now what we're going to do is clean this up. We could get a single fraction on the numerator and then multiply by the reciprocal of the denominator. So like 3 over 3 plus 2 over 3 is 5 over 3. We could do all of that. Again, one of the nice strategies is to multiply by the common denominator, which is going to be 3 in these fractions. So this is going to be the square root. I'm going to multiply 3 to everything on the numerator. Is going to be 3 plus 2 divided by 3 times 2, which is 6. So this is going to be the square root of 5 over 6. And I believe that answer would be accepted In case it's not, what happens if our digital won't accept that, you would have to rationalize the denominator by multiplying by root 6, and we'll get root 30 divided by root 6 times root 6 is just 6. So square root of 30 divided by 6. Okay, but I think this answer right here would be accepted as well. It just depends. Okay, all right, so that is how we work with a given ratio. All right, last two examples with that. Let's stay on example 5 for now. Here, sine of b is 4/5. Find the exact angle of tangent. So we haven't done too much with tangent yet, where cosine of b is greater than 0. Okay, so let's go ahead and take a look at our tangent formulas. Here we're given sine of b, and we're asked to work with that. So our tangent has these 3 options. I recommend working with the one that's probably the easiest to manipulate. And the easiest one to manipulate usually is the one that has only a single term on the denominator. You definitely could do this one. I would absolutely avoid using the square root one whenever possible. So let's go ahead and take this 1 minus cosine x divided by sine. Okay, so we're trying to find tangent half angle. So tangent of b divided by 2 is going to equal 1 minus cosine of the angle b divided by sine. So watch what you're writing down. Sine of b. So that's what we're going to look to substitute into that. So we have 1 minus something divided by something. So this, we're picking a formula, expanding it. I'm going to go ahead and draw my scenario. Sine b is 4/5. That's a nice ratio that we hopefully like. And cosine is positive or greater than 0. So if sine is positive and cosine is positive, then we must be in the quadrant where both of them are positive, which should be quadrant 1. Again, so sine is positive, cosine b is also positive. We must be in quadrant 1. Okay, so sine is opposite over hypotenuse. So we get 4/5, and this is a nice triple of 3. So on our numerator, what is the cosine b ratio? Cosine is going to be adjacent, which was not given to us. So we do have to calculate 3/5. And then sine b was given to us is 4/5. All right, so interestingly, tangent doesn't use the tangent ratio in half angle formulas. So this is going to be our piece. Again, I could show this one a little bit different way. You could do a compound fraction. So this is like 5/5 minus 3/5 divided by 4/5. So my numerator, 5 minus 3, with my common denominator, is going to be 2/5 divided by 4/5. And then you multiply by the reciprocal of the denominator. So these will cancel. And you're left with, those will reduce. So we're left with 2/4, which is 1/2. All right, so we get an answer of 1/2. Again, if you wanted to try the strategy, let's say we went back to here and we left it as 1 minus 3/5 divided by 4/5, you can still multiply the numerator and denominator by a common denominator. So if we take a look at this, as long as we balance it, put brackets around this too, the common denominator is 5. So if we multiply the numerator and denominator by 5, this is another algebraic strategy of simplifying, and you'll take this 5 and multiply it to both terms on the numerator. You're going to get 5 times 1, which is 5. 3/5 times 5, the 5s would cancel, we'll just get 3. And 4/5 times 5, the 5s will reduce out, and you're left with 4. So we get 2/4, which is still 1/2. So you get the same fraction very quickly. Okay? All right. So either way, we get 1/2 out using some algebraic strategies. All right, our last example is simplifying sine half angle times cosine half angle. And there's a couple different ways to do this problem. I encourage you maybe to pause the video, look at our formulas. What could I substitute in and start simplifying this down to that, even though I don't know what the answer might be. Okay, so for this one, we have 2 angles. I'm trying to put parentheses around here and here. We have 2 half angles. So sine half angle, I'm going to rewrite that formula or identity is 1 minus cosine of, we're dealing with x's, so I'm going to go ahead and use x divided by 2. Okay, and that's our first term. Our second term is times cosine half angle, which is also the square root 1 plus cosine of x divided by 2. Okay, so we have these two are being multiplied together up here. I'll get rid of this parentheses in the way. So I'm multiplying a half angle times a half angle. Okay, so when that happens then, when we have 2 square roots, we can actually merge it into 1, and we're going to have 1 minus, I'm going to multiply these 2 fractions together as I do this. 1 minus cosine x is on our numerator times 1 plus cosine x on the other numerator. And they both have common denominators that when we multiply together, we should get the number 4. Okay, so that's what that's going to happen as we substitute out the half angle identities and substitute in. So now this is going to become the square root. This is the difference of two squares, 1 minus cosine times 1 plus cosine. So it's going to be the a squared minus b squared. So it's going to be 1 squared, which is 1, minus cosine squared x divided by 4. Okay, and then that's going to equal the square root. Well, 1 minus cosine squared x. Where have we seen that before? That's why we really like the difference of two squares. That's an identity from our Pythagorean identities. That is equal to sine squared x over 4. And we're square rooting everything. Well, guess what? Sine squared of x square rooted is just going to be sine of x. And square root of 4 is going to be 2. So this half angle times half angle ends up being sine of x divided by 2, or a half of that. Okay. Another way that's not as common to see done for this simplifying, and it's really is optional, but I just want to show it because it's really creative when a student comes up with this, is to look at it as it's sine half angle times cosine half angle, which looks similar to the sine double angle identity. So if we took a look at this, sine of x over 2 times cosine of x over 2, if it had a 2 out in front of it, it would look just like the double angle identity, but with half angles in the angle positions. So if we were to get creative and put 1/2 times 2 times sine half angle, cosine half angle, that is the angle identity. So this piece right here, this piece, which is equivalent to our original given that we're asked to simplify, that can be rewritten as 1/2. 2 sine times cosine is sine of a double angle, or 2 times x over 2, which will simplify down to 1/2 sine of 2 times x over 2 just becomes x. And right here, these last two pieces are the same. You can write it as 1/2 sine of x or sine of x divided by 2. So we can actually do this identity multiple different ways, and here's 2 ways that I have shown. Thanks for watching.